The Fighting Falcon, a U.S. instrument of power in the air. The key to keeping it safe while flying is effective and safe maintenance. The single intent of safety in aircraft maintenance is to enable the aircraft to continue performing its mission effectively without safety mishaps. Every maintenance action has its safe method of operation, and this videotape will cover some general guidelines for approaching any maintenance action on the F-16 aircraft. Technical Order 1F-16C-2-10JG-00-1 and 1F-16C-2-00GV-00-1 cover the procedures mentioned in this videotape. No matter what the specialty, be aware of the hazardous areas around the F-16. These areas include the engine inlet and exhaust, areas of high noise, areas of radiation, areas around exhaust ports, areas around movable surfaces, areas near planes of rotation, firing paths of loaded munitions, and areas near hot breaks. Refer to your tech order for the dimensions of these areas. Hazards presented by the engine inlet are those of ingestion and high-frequency fan noise and vibration, while the exhaust area mainly represents hazards of blast, temperature, and noise. The sizes of the hazard increase with increase in engine rotation. Only remove or install the nose landing gear safety pin after the engine has been shut down. Be aware of the aircraft as it turns. You can be safe 1 minute and in direct line with the exhaust the next. In addition to the areas around the engine, potentially damaging noise levels are also generated in the area of the jet fuel starter. Areas of RF radiation around the F-16 are also considered hazardous. These are generated by the UHF, IFF, TACAN, VHF systems, and radar. If ECM pods are loaded on the aircraft, these will also generate a radiation hazard. Refer to your tech data for dimensions of the hazard areas. The greatest radiation hazard is produced by the fire control radar, with its hazard cone extending approximately 120 degrees. In addition to the personnel hazard, the radiation presents a possibility of explosion of electro-explosive devices and ignition of the volatile liquids within the zone of radiation. Hazards due to extremely high temperatures exist at exhaust ports of certain F-16 systems. The convergent exhaust nozzle control, the jet fuel starter, and the emergency power unit all develop exhausts in excess of 1,000 degrees Fahrenheit. The environmental control system's exhaust is over 300 degrees Fahrenheit. In addition to the high temperatures, another hazard exists in the EPU exhaust. Warning: special care must be taken when working around the EPU exhaust. The exhaust may contain toxic hydrazine. Stand upwind while the EPU is being fired or after it has been fired to avoid possible fumes. Another portion of the F-16 which creates a hazard for movement around the aircraft is the movable surfaces. The flight control surfaces and the hydraulically actuated doors on the F-16 are fast-acting and powerful. First, the leading edge flaps, flaperons, and horizontal tail are relatively sharp and low enough to cause injury if personnel accidentally walk into them. These surfaces and doors present moving hazards when electrical and hydraulic power are applied to the aircraft. These surfaces and doors are leading edge flaps, flaperons, horizontal tail, speed brakes, rudder, air refueling door, and the canopy. Under the F-16, movable surfaces danger exists from the JFS intake and exhaust doors, the gun gas purge door, and the landing gear and landing gear doors. Other protrusions which present hazards on the aircraft are the angle of attack probe, the air data probe, and static dischargers on the wings, and the horizontal tail. Hazards due to planes of rotation need to be considered. During engine start, stand clear of the plane of rotation of the jet fuel starter turbine and the main engine turbine plane of rotation. The firing path of loaded munitions constitutes another hazard to personnel. Maintenance personnel must be especially cautious when working around live missiles, a loaded gun, or loaded chaff or flare modules. An aircraft that has experienced hot breaks presents a potential hazard in two areas: fire and exploding tires. Tires may blow out without warning because of the heat generated by a hot break condition. Danger areas extend in a cone shape from each side of the tires. Avoid these areas, if possible, for the specified time period after the aircraft has stopped. If the tires must be approached, approach them from a line of roll only, and if the engine is still running, remember the inlet and exhaust danger zones. Maintenance procedures in the job guide start with ensuring the aircraft is in a safe condition and return it to the same safe condition following completion of the maintenance task. The aircraft is considered safe for maintenance if all external locking devices are installed and all cockpit devices are in the positions mentioned in your tech order. Let's examine the external portion first. Warning: do not enter areas under the arresting hook, external stores pylons, external fuel tanks, and chaff flare dispenser until all applicable safety pins have been installed. Failure to comply may result in serious injury or death to personnel. Ensure chocks are in position forward and aft of each main landing gear wheel. The landing gear ground safety lock pins must be installed in the main landing gear struts and the nose gear lock pin in the nose landing gear strut. Ensure that the aircraft is properly grounded. Check to ensure that the EPU ground safety lock pin is installed. Warning: if the brick orange colored detector changes to deep purple or black, there is hydrazine or its vapors in the area. Immediately clear the area of unnecessary personnel and initiate spill cleanup procedures per your tech order. Visually check the hydrazine detector through the sight glass for any sign of hydrazine leakage. If hydrazine leakage is present, clear the area of unnecessary personnel and initiate cleanup procedures as specified in the tech order. Ensure the arresting hook is up and locked and the ground safety pin is installed. If the hook is not up and locked, lock it in place as described in your tech order and install the lock pin from the left side. Some bases require installation from the right side. If external stores with explosive cartridges are installed on either or both wing pylons and the centerline pylon, ensure that the bomb rack ground safety lock pins are installed. If the tow reel is installed, ensure that the tow reel piston safety block and the tow reel release pin is installed. If the external fuel tanks are installed, make sure that the lock pins are installed. Also, if chaff and/or flares are uploaded, ensure that the chaff flare ground safety lock pin is installed and make sure the gun firing safety pin is installed in the gun firing circuit. Note, this pin may be installed externally or internally. Check with local base procedures before installation. If a missile or missiles are loaded, ensure that the AIM-9 launcher safety pins are installed. Remember, external safety depends on careful attention to the recommended procedures. Let's examine the interior portion of the aircraft's safe for maintenance criteria. The interior portion will address conditions in the cockpit, and before entry is made, we must determine that the cockpit is, in fact, safe for entry. Ensure that the canopy is open and that the crew entry ladder is properly positioned. Warning: when positioning the crew entry ladder, avoid any contact with the throttle. Allow the strake support to rest against the fuselage and ensure the ladder is properly aligned. There are markings on the aircraft to ensure the alignment, and you should ensure the ladder is hooked securely over the forward cockpit canopy seal. Now, make sure the ladder strake support is extended and the quick release pin is installed. Apply pressure to the bottom step to check proper engagement of the ladder. Warning: do not enter the cockpit until all safety precautions have been verified and accomplished. Failure to observe these precautions can result in injury to personnel or damage to the aircraft. Let's take these safety precautions step by step to understand them. Ensure that the canopy jettison handle is fully seated and the escape system safety pin is installed. Ensure the seat ejection control safety handle on the left side of the seat is in the up or ejection control locked position. Warning: a missing or broken rivet connecting the control rod to the seat ejection safety handle will allow the ejection seat to remain in an armed condition with the safety handle in a locked or up position and the safety pin installed. Failure to ensure the rivet is secured may result in serious injury or death to personnel. In light of the serious consequences of having an improperly installed rivet in this position, check that the control rod connecting rivet in the seat ejection control safety handle is properly installed and that the escape system ground maintenance safety pin is installed. The seat restraint emergency release handle on the right side of the seat should be in the down position with the escape system ground maintenance safety pin installed. On the right side of the seat, the recovery sequencer indicator should be white, signifying an operational condition. Warning: if the recovery sequencer indicator is red, wait 2 hours to ensure the sequencer is inert before performing any maintenance on the seat. The seat contains ballistic devices which passes the rail-mounted striker. Detonation of the devices can cause injury to personnel. Make sure that the green emergency oxygen manual pull ring has not been actuated. Check the lap belt and make sure it is connected. Also, ensure the survival straps are placed on the seat bucket. Install the protective cover on the HUD combining glass. That completes the actions required to make the cockpit safe for entry. You can now ensure that the aircraft is safe for electrical power application. This requires a whole new set of actions which must be performed in the cockpit. There are many switches inside the cockpit that need to be checked. Since you are already sure that the aircraft is safe for entry, we will list all switches and their positions. Probe heat switch, off position. EPU gen test switch, off position. Oxygen quantity switch, off position. FLCS power switch, maintenance position. Defog lever, mid-range position. Tank inerting switch, off position. ENG feed switch, off position. Air refuel switch, close position. IFF master switch, off position. EPU mode switch, off position. Main power switch, off position. Master switch, off position. Max power switch, off position. Starting fuel switch, auto lean position. EEC buck switch, EEC position. Note: the last two switches may be different depending on the aircraft configuration. Consult your job guide. Jet fuel start switch, off position. Hot mic switch, off position. TACAN control, off position. ILS control, off position. COM1 and COM2 switches, off position. UHF function switch, off position. Throttle off. Dogfight switch, center position. Alt gear handle, fully seated. ECM mode switches, off position. Note: The last two switches may be different depending on the aircraft configuration. Consult your job guide. Emergency stores jettison switch, plastic cover intact. Hook switch, up position. GND jet switch, off position. Brake switch, channel 1 position. Brakes selector switch, anti-skid position. Lights switch, off position. Landing gear handle, down position. TF switch, off position. Pitch switch, off position. Roll switch, off position. Master arm switch, off position. Laser arm, off position. SIM and INT controls, off position. Drift CO warning reset switch, norm position. Gain auto switch, LVL position. Fuel quantity select switch, norm position. X fuel trans switch, norm position. AVTR power switch, off position. Left hardpoint power switch, off position. Right hardpoint power switch, off position. FCR power switch, off position. Radar altimeter power switch, off position. Nuclear consent switch, off position, and guard is down. Chaff flare mode switch, off position. Primary consoles control, fully counterclockwise. Primary instrument panel control, fully counterclockwise. Primary data entry display control, fully counterclockwise. Flood consoles control, off position. Flood instrument panel control, fully counterclockwise. Temp switch, auto cool position. Air source switch, norm position. Anti-ice engine switch, off position. FCC power switch, off position. SMS power switch, off position. MFD power switch, off position. UFC power switch, off position. INS switch, off position. GPS power switch, off position. TISL power switch, off position. MAP power switch, off position. Oxygen supply switch, off position. Note, due to different aircraft configurations, some switches may or may not be found in the cockpit. Consult your job guide or tech order for additional requirements. This concludes the actions necessary to make an aircraft safe for application of electrical power. If your scheduled maintenance requires application of hydraulic power, refer to your tech order for the necessary preparation. This tape by no means covers all the maintenance actions for which a safe aircraft is a prerequisite. It does, however, provide a means to establish a common base to start with using an aircraft safe to work on and in.